Okay. I mentioned it previous lecture just to make sure you all know that this is the first lecture for exam 2, okay? It's not going to be part of first exam. Okay, it's called Thévenin and Norton equivalent circuits. Let's start with Thévenin equivalent circuit. What does it mean? So let's just let's assume that we have an electrical network made with resistors, dependent source, and independent sources, okay? All of them, thousands of them. And then we are connecting all of that to some RL resistor. First of all, can you just tell me what should we call RL in technical terms? What do we call it? The load, okay? What does it mean? It means that this is not part of your design. You design the electrical network and then connect it to some sort of appliance or something, and the network tries to deliver something, some power to the load resistors, okay? So RL is not part of your design. It's something that is supposed to work based on your design. Now, what Thévenin equivalent circuit does is to model the whole electrical network with a very simplified circuit made of only one voltage source and one series resistor. Why is that important to us? Because it simplifies our analysis very much, right? So instead of the thousands of resistors and voltage sources and current sources and dependent sources, we can just replace all of that with one voltage source and one resistor. And RL, let's say that I'm connecting RL here. And RL wouldn't feel the difference, wouldn't sense the difference. In other words, let me ask you this question. I have a black box, and from the terminals of the black box, a RL is connected, okay? And I measure the voltage or the current that is feeding RL. How can I make sure that inside the black box is the left circuit or the right circuit? How can I do that? I can't. That's what equivalent means, okay? So it means that if you can't see inside the black box, it could be 1,000 elements or it could be just that, okay? Both of them are going to do the same thing. Now, any electrical two-port network, two-port, obvious reasons, can be replaced at the terminals by its equivalent Thévenin circuit. Now, I want you to remember this because it could be a conceptual question on exam. The Thévenin equivalent circuit consists of a voltage source, VTH, in series with a resistance, RTH, the TH for Thévenin. I want you to remember this because if you have a current source in parallel with a resistor, that's called Norton equivalent circuit, okay? Now, how can we calculate VTH and RTH? Let me ask you this. I have a black box and I'm giving it to you and I want you to find VTH for me. You cannot have access to inside the black box. How do you measure VTH? Yes. And since you're connecting a multimeter as a voltage meter or voltmeter, it means that your circuit is open, okay? It's not drawing any current. Why do we need that? Why do we need our circuit not to have any current? Because we don't want a voltage drop across RTH. See, if there is no voltage drop across RTH, do you agree that the voltage that you measure at the terminal is exactly equal to VTH? Do you all agree with that? If there isn't any current passing through RTH, what's the voltage drop across RTH? 0. So, yeah. So what is VTH? Is the open circuit voltage measured or calculated across the terminal. Open circuit, okay? Now, one thing that I want you to know is that inside the electrical network, there might be multiple independent sources, okay, or dependent sources. You shouldn't touch any of them. You shouldn't kill them. You shouldn't eliminate them from the circuit, okay? Because what you want to find at the terminals is the effect, the overall effect of everything inside the network. So don't alter the network, okay? Just keep it as is. While all independent sources are alive, meaning that you didn't mess with them, okay? So we found the first parameter, VTH. The next one is RTH. What is RTH? So let me ask you this. Let's again bring up the black box. Do you have some equipment in this lab that you can measure RTH with? What is that? Multimeter. What mode should you put it on? The ohm meter, right? And do you need to do something to the circuit before measuring that? Quite the opposite, actually. Turn it off. Why? Let's see. If VTH is not there and you connect a multimeter across the terminal, you are going to measure RTH. Isn't that correct? If VTH weren't there, what would you measure by connecting the multimeter across the terminal? You would measure RTH. As simple as that. Imagine it's just one resistor RTH. You would measure that, okay? So that is the step required for measuring the Thévenin resistance. Kill all the independent sources. The circuit shouldn't be energized, okay? Oops, what did I? Equivalent resistance seen at the terminals of the network while all independent sources are dead or eliminated. I want you to understand this wording of that. Seen at the terminals, okay? I usually show it using that. This is how I show it. What does it mean? It means that if you stand at the place where your load is located and then look to the circuit, imagine that you have some superpower to sense resistance, okay? The value of the resistance that you sense or see is equal to the Thévenin equivalent resistance. Now, you don't have to have the superpower. You only have to have one multimeter to do that, okay? So that is how I usually show it. And yeah, any questions so far? Yes?
So when we measure the resistance, is the RL is there or no, or is it open circuit?
For measuring the resistance, no, RL shouldn't be there.
Okay.
Yeah. And the reason for that is that if RL is there, then your multimeter will show R Thévenin in parallel with RL. And also, remember, RL is not part of your analysis or design or whatever. RL is the appliance that is going to receive your service, okay? For those of you who end up doing this job. Okay, how do we kill independent sources? How do we kill a voltage source? Why? Volt, how can you set the voltage to 0? Wire. Wire is a voltage of 0. How can you make a current source dead? By opening it, because the current becomes 0, right? So remember, voltage source, short circuit, current source, open circuit. Now, find the Thévenin equivalent circuit as seen by the 1 ohm resistor. First of all, I want you to pay attention to this. As seen by. Remember, on your exam, the 1 ohm resistor is not red. Okay, so you have to understand it yourself. What do you call? Give me a good label for the 1 ohm resistor. RL. See, that's not part of your analysis. So remove it as soon as you see or you understand which one is actually your load. Okay, so remember, this is your RL. It's not part of your analysis, your circuit, or whatever. It's the load that's supposed to receive something from the rest of the circuit. So, in fact, I'm going to draw something for you here. So this is your black box, and that is your load, okay? Does it make sense what I meant by doing that? Okay. Very good. Now, let's calculate VTH. So what should I do to calculate VTH? Should I include the 1 ohm or no? So what should I do with those two, like, hanging in limbo terminals? Short or open? Open. Remember the definition of VTH. What is VTH? It's the open circuit voltage, right? Okay, how should I solve this? I want to find VTH. From now on, until we find VTH, everything is actually your exam 1 material. So you should be able to do it. For example, if this is given to you and they just ask you to find Vx across the terminals, you should be able to do it. So how do you do it? Mesh. Let's do mesh. I1, I2, I3. How many unknowns do I have? 3? 3 or 2? What is I3? What is it? Why? Open circuit voltage is Thévenin, right? So that loop, that mesh is open actually. So I3 is 0. Okay, so let's write KVL at I1. So I will get negative 4 plus 9 I1 minus I2 plus 3 equal to 0. Then KVL at I2. If I mess up, let me know. 9 times I2 minus I1 plus 10 I2 plus 5 I2 plus 10 I2 minus I3 is equal to 0, and remember that I3 is actually 0, right? Okay, so do I need to write the KVL around I3 as well? Well, if you are looking to find the currents, no, you don't need to, because the current of that specific mesh is 0 since it's open. So give it to your calculator and give me the value of I1 and I2. Braylon, I saw your email very late. That's why I didn't answer. Was it due last night? I think you sent it 8:30 p.m. That time I'm dead. I honestly I didn't understand what the problem was. Come to me after the lecture is done. See. Waiting. I1, I2. If you don't know how to use your calculator, you will learn it next quarter. Sorry? Give me some real value, engineering value.
Okay, negative 0.151.
Yes. No, it's not negative. Positive. 0.1511. That is what I have. For the other one, 0.04. Am I done with finding VTH? No, you didn't find it. You just found the currents of the circuit. But the next step could be, it's not that difficult. Okay, what should I do now? What do you mean nodal? You just did mesh. You solved the circuit. Now, give me VTH. Always remember what you're looking for. What kind of animal is it? Is it voltage, current? What is it? Voltage. What do you do when dealing with voltages? Either you go for Ohm's law or KVL. So can I apply Ohm's law to VTH to find it? No, it's an open circuit. There's no resistor there. How about KVL? Is VTH part of a loop or a mesh that I can write KVL around. Why not? Remember him and me. Can I write KVL around any loop even if it is open? Yes. Okay? So when try to look at him once in a while on exam, okay? So you don't forget this. Any loop, whether it is open or closed, you are allowed to write KVL around. Okay? So let's write KVL. Tell me, what should I write? Negative 3 plus, no, 10, I3 minus I2, which is negative I2, yes. Then, this is the important part. What's the next term? VTH. Because you're entering from the positive terminal. What's next? Well, 10I3, but it's actually 0. Equal to 0. Okay? So what I have is then VTH is equal to 3 plus 10I2, which becomes 3.4 volts. We found VTH, okay? One thing that actually one student did, and I sort of liked it. I never did it this way, but it was interesting. For the 3 meshes that you assigned initially, okay, we wrote only two equations. Why didn't we go for the third equation to write a KVL at I3? Because I3 is known, right? But what if you write the KVL for the third mesh, knowing that I3 is known, but it will add one variable or one unknown to your set of equations, that is VTH. So you will end up 3 equations, 3 unknowns. I don't know which one you prefer, doing one set of 3 equations, 3 unknown, and finding the answer directly, or doing 2 equations, 2 unknown, and then do another extra KVL. I believe the student's version is better than mine, but whatever you're comfortable with. Okay, so that is the voltage. Let's do it one more method. So let's do nodal and see what happens. So I'm going to assign a ground, right? Are you focusing on my pen? Did I just do something wrong or no? I just ran over the resistor. Am I allowed to do so? Usually no, but am I allowed to do it now? Why? There's no voltage drop, so it's like a piece of wire. Just ignore it. What is the red one? 4 volts. Okay, I'm going to give you a statement. It's a tricky statement, and please tell me if it is true or no. As soon as I see the circle with the positive and negative and 4 volt, I can assign the top terminal to 4. What's wrong with that? You need the negative terminal to be grounded in order to write that as 4. If the negative terminal was connected to V1, some random voltage, what would you write to the red? V1 plus 4. Okay, this is a very common mistake. don't just assume, don't take it for granted that the negative terminal is grounded, okay? Okay. What is the purple voltage? 3 volts. Let me do something to make my case a little easier. I'm going to get rid of the 5 and write the 10 as 15. Okay, they are in series. So I don't have to consider an extra node in my calculation. What should I call the green one? Give me a good name. V2 is good. VTH. I want you to see this. See, the negative terminal is ground. The positive terminal is exactly VTH. That will make everything much more obvious. Okay, so what should I do now? Write KCL at the only unknown node, VTH. So start with who? Can you start? Yeah.
VTH minus 4 over 15.
Plus, next.
VTH minus 3 over 10.
Next. Next. VTH minus 0 over 10, is that good? No, it's not. It's very ugly. Okay, what is KCL, guys? Currents. Adding all the currents that are leaving the nodes and set them equal to 0. So the current top to the left, you set it. The middle one to the left, you set it. What's the current leaving that node downward? 0. It's open, right? So plus 0 is equal to 0. One equation, one unknown. Okay? Where did I get 3.4? From the previous one. But just multiply it by 15, for example, and get rid of the denominator and just one equation. Now, which one would you prefer to solve for VTH? Nodal? Nodal is one equation, one unknown. VTH is, mesh is actually 3 equations, 3 unknowns. Which one would you prefer? Definitely nodal. But here is my point. Is that the end of the word if you went for mesh? No, it takes probably 2 minutes more. So that's what I meant by not doubting yourself in the middle of the problem. If you chose something and it's not, hopefully it's not stupid, go for it, okay? Finish it. Don't leave it midway, come back, choose something else, okay? See? There's not much difference. Okay, what's the next thing that we want to find? R Thévenin. What should I do if I want to measure R Thévenin? Yeah, first of all, kill the voltage sources and current sources if you have. Replace them with short circuit. Something else. You actually asked the question. In my setup, RL shouldn't be a part of that, okay? RL is not your concern. So remove that. Oops. So I removed that. Now, this is a question that you've actually tackled before. The terminal, look at the terminal. Are the terminals open? If the terminals are open, then the resistance is infinite, right? So always the resistance is infinite. So what's the point of measuring that? Should let's suppose that you are required to do this in your lab, in your mini lab. What would you do to measure resistance? So it's not open. It's connected to a multimeter, okay? Now, because you have the tendency to forget that, I'm asking you to do this. Draw it. And write a multimeter here. So you know that this is actually connected to a multimeter. And we want to measure RTH from across these terminals. Okay. What should I do? Remember, you don't care about the multimeter, you just want to make sure that you don't forget those two terminals are not open. They are connected to somewhere. What should I do? Why? Do you agree? Short out the 9 ohm? Okay. If you don't see that immediately, if you don't see the 9 ohm is shorted immediately, what is the solution for that? Colors, different colors, okay? Then it will be much easier to detect them. Let's apply colors and see what I mean by that. Okay, that's one of your node. What is the other one? Let me again do the 5 and 10. Combine the 5 and 10 since this is 15. And also this guy. Now, if I want to find which resistors are in series, which ones are in parallel, which ones are shorted, I just look at the colors. For example, the 15 and 10, what are they? Why? They have the same two colors. They are between the same two colors, green and purple, right? Now, how about the 9 ohm? Shorted, why? Because it is between green and green, so it is shorted, okay? So 9 ohm, short circuit, not short circuit, So I'm going to remove it. What is left? So you agreed that 15 and 10 are in parallel, right? And then the combination of them is in series with the bottom 10 ohm. Any problem with that? Okay, I found the Thévenin equivalent circuit. So let's do this. Question. I have a 1 ohm resistor connected to a black box and I have multimeter measurements. Which one of these two circuits is inside the black box? One or two? We don't know because they are completely equivalent. Okay? That's the equivalency means. Okay? Now, can you give me another representation of the black box? What's inside the black box? Based on the previous lecture. So, what's the value of the resistor? 16 ohms. What's the value of the voltage source?
3.4 volts divided by
Multiply by 48 plus, no, plus 6.4.
why is it a voltage instead of current?
Oh, sorry. Thank you. My bad. Should divide it. 3.4 divided by 16. Oh, good Lord. I don't know what that is. You have calculators. This is based on source transformation, right? That's not a new concept. We did it based on the previous lecture. That's exactly the next topic. So that one was called Thévenin equivalent circuit. This guy is called Norton equivalent circuit. So Norton equivalent circuit is like that. We call the current INO and we call the resistor RNO, but as you know, the Norton resistance and Thévenin resistance are exactly the same. So instead of creating a new name RNO, we just call it RTH because they are exactly the same. Now, let me ask you one question. How, if you have a multimeter, how do you measure INO? Sorry? You have to connect the multimeter to the terminals, right? But what if you want to calculate it, pen and paper? How do you calculate what is INO if you don't have access to the inside?
We could find whether it was and just use AC voltage and resistance.
Okay, indirectly, yes. Directly. How do you calculate INO? Let me ask you this. You only have access from outside, right? You don't have access inside the black box. And you want to calculate or measure INO. So we want a way to let all of INO come out of the black box and nothing goes through RTH, right? What's the way to do that? You short circuit. Remember the duality that I talked about? How do you measure VTH? Open. How do you measure short INO? Short circuit, okay? So hence the definition of INO. INO is the short circuit current measured between the terminals of the network. Should we do anything to the independent sources? No, let them be. Don't touch it. Also, remember this for the conceptual questions on exam. Norton equivalent circuit consists of a current source INO in parallel with a resistance. You want to call it RNO or RTH, doesn't matter. This is just a note so you remember that if your INO is I'll get back to you in 1 second. If this is your INO, the short circuit current that you measure from top to bottom for obvious reasons. See, the middle resistor is shorted out, so the current rotates in this way. Yeah?
For the conceptual question, the possible conceptual question on the test, if you put RTH or RNO, given that it was in parallel or series how it's supposed to be, does it matter which one of the two resistances are there in question?
No, it doesn't matter.
Making sure.
Yeah. The only thing that matters is that it should be current source and it should be parallel. They might even call it equivalent resistance. They are the same thing. And this is something that we, it's like the chicken and egg. We don't know which one is the result of the other one. You want to talk about first Norton and Thévenin and then say source transformation, or teach source transformation first and then decide Norton, or find Norton from Thévenin. But the important result here is this. Imagine that you have a question, you have a circuit on your exam, second exam, and it's asking you 3 questions in order. First, find VTH. Second, find INO. Third, find RTH. This is my suggestion, okay? On exam, find the 2 easiest one based on circuit analysis. How about the third one? Ohm's law. We just proved that they are very closely related, right? You remember how we calculated this? We didn't do any circuit analysis for that current source. We just divided the Thévenin voltage by RTH. So remember not to do circuit analysis for all three of them. Okay. The same example, we know that we can just find INO. We actually did find it. But let's just do an analysis and see what we can do. So what should I do? What's the first step? Get rid of the stranger. Who's the stranger? The 1 ohm resistor doesn't belong here. Then short circuit. That is your I and O. One thing that you need to know is that usually on exam and or on web work problems, you will get the direction or the polarity from the statement of the problem. But here I'm just going with the default assumption. Okay, so what do you suggest I do? I want to find I and O. Yeah, let's go for mesh. So let me first combine these two, since it is obvious. Okay. So I1, I2, and I3. KVL at I1 is -4 plus 9 I1 minus I2 plus 3 is equal to 0. KVL at I2, 9 times I2 minus I1 plus 15 I2 and plus 10 times I2 minus I3 is equal to 0. KVL at I3, -3 plus 10 times I3 minus I2 plus 10 I3 is equal to 0. 3 equation, 3 unknown. Which one you're interested in? Only I3, right? So give me the value of I3, but please do it on your calculator. Don't give me the value that we already have. As soon as you get to the value of I3, let me know. 0.2125 amps. Any question? Anyone interested in doing this using any other methods, or you're good? Did you at any point thought nodal would be do you want me to do it nodal? No? Okay? Okay, next example. Find VTH, INO, and RTH for the circuit shown below. Let's first go for VTH. So here is your VTH. And remember that it is open, okay? Open circuit. So what do you suggest? Mesh, nodal, what? Nodal? Let's do both, huh? Okay, let's do mesh first. I1, I2, and do you want to do like my students did it? Yeah, let's do that. Let's consider this I3. You know I3 is 0, right? I3 is 0. But let's just write it. Okay, so KVL at I1. -3 plus, I'm writing all the resistors in kilo ohm and currents are in milliamps. Sorry, I shouldn't have written that. I should write KVL at I1 or no? No. I should write KVL at super mesh of I1 and I2. So -3 plus 2I1 plus 5 times I2 minus I3, which is 0, equal to 0. Okay? One equation, two unknowns. What's the next? I1 minus I2 is equal to 7 from inside the supermesh. Okay, two equation, two unknown. I'm going to do something different from the last time that I did mesh. I'm going to write a KVL around I3 as well. So extra equation from inside the supermesh. And finally, KVL at I3. Usually you don't write KVL at I3 because it's 0, you know it. But what would it help with? Finding VTH. So let's write the KVL. So 5 times I3 minus I2, which is actually negative I2 because I3 is 0, plus 1 I3, again 0, plus VTH is equal to 0. Did that make sense to everyone? So three equations, 3 unknown. You can find VTH from that. If you don't like that, Don't write this. 2 equations, 2 unknowns. Find I1 and I2, but you have to take another step because you need VTH. Now, whatever you're comfortable with VTH. I believe this is not a bad idea to just include that because I don't think giving a 2 equation, 2 unknowns to your calculator or 3 equation to a 3 unknown would matter that much. Yes?
Well, would the name change if you added a resistor in series of that current source?
No. No.
Is it order without a resistor?
Yeah. First of all, let me talk about 2 cases. If there was a resistor in series with a current source, would that change my KVL at the super mesh? No, because you go around that. You don't consider that branch. How about the extra equation that I write from inside the super mesh? See, even if there is a resistor in that branch in series with that current source, still the current passing through that branch is forced by the current source, 7 milliamps. So it doesn't matter if there is a resistor or no. In fact, if you remember when I was talking about super mesh, I mentioned anything in series with the current source is also inside the super mesh. If you remember for nodal, what was the statement? Anything in parallel with the voltage source goes inside the super node. So that's the duality. Okay, so whichever you find more comfortable, you can find, and here, give it to your calculator and tell me the value of VTH, please.
7.86.
Thank you. That is your VTH. Using mesh analysis and using nodal. So 1 here, 1 here, did I mess up? I shouldn't have done that, right? I shouldn't have ran over the 1 kilo ohm resistor, but I did. Why? That guy is part of an open circuit, so it doesn't have any voltage drop. So it's not creating new nodes for you, right? What do you label the purple one? VTH. What do you label the red one? 3 volts. So you only need to write one KCL equation at VTH. VTH minus 3 divided by 2 plus 7 plus VTH minus 0 divided by 5 plus 0 equal to 0. And VTH is equal to negative 7.86 volts. One equation, one unknown. Any problem? What's the next thing that you want to find? Let me ask you if it was on an exam. So, what would you choose as the second analysis? RTH. Is that obvious for everyone? Why is it a much better? Let me do it actually. So can you tell me what I should do? Get rid of the sources. What should I do with the 3 volt? Short. The current source? Open. Now, I don't want to draw the multimeter, but I want you to remember that there is something connected there. Okay, it's not open. And if you think you will forget it, draw the multimeter. But is it very easy to find RTH now? Can you tell me what is it? 2 kilo ohm in parallel with 5 kilo ohm plus 1 kilo ohm. Do you see that 2 and 5 are in parallel? And then whatever combination they have is in series with 1. I don't have RTH. Where is it? Okay, 2.43. Why did I choose RTH over INO? Because INO requires a full circuit analysis, but this one is just equivalent circuits, probably easier. And now I can easily say what INO is. What is it? Yeah. So negative 7.857 divided by 2.43. This is volt. This is kilo ohms. What is negative 3.23 milliamps. This is what I have. But just for the sake of completeness, let's analyze the circuit for INO, okay? What should I do? Short the output. This is INO that you need to calculate. Which method would you choose? Mesh. Let's do something crazy, huh? No. No? Let's not do either mesh or nodal. Let's do source transformation. Those two are probably straightforward for you, I hope. So this is my guy. I'm going to remove this. And I'm going to change it to a resistor in parallel with a current source. The value of the resistor should be 2 kilo ohms, and the value of the current source is 3 volt over 2 kilo ohms, which is 1.5 milliamps. What's the next step? So I'm going to get rid of the current source and just write the 7 as 7 minus 1.5, which is 5.5. I'm combining the current sources in parallel, right? And
All the resistors are.
can I just make all the resistors parallel? What's wrong with that? They are in parallel. What's wrong with that? We need I and O, which is passing only through one of them. If you combine all of them, you're combining their currents, so you don't have access to I and O anymore. So let's combine the rest of them. So what is the parallel of 2 and 5? 10 over 7. What is I and O?
10/7 divided by 17.
Right? Anything wrong with this? The direction, it needs a negative sign. The way the current is feeding the rest of the circuit, the current should come up, not go down. So we need a negative sign. You remember this? I drew it once for you. Right? The value is negative 3.23. And if, in case you didn't know that, that was current division. Problem? Do you want, I hope you don't, but do you want me to do nodal and mesh for the last one or no? I mean, honestly, it doesn't worth it. It's not that of a complex circuit, right? So you can do either mesh or node. Whatever I choose in class doesn't necessarily mean it's the best. Sometimes actually intentionally it's the dumbest way. So you can get some confidence. But I mean, even if you choose the dumbest possible method, you're still gonna get to answer. You're not gonna lose like half an hour of time. And yeah, and also it's a good practice.